Cool, doing a video here for all you YouTubers. I'm going to actually attempt to fix an oil burner. This is my neighbor's. We have no idea what's going on, so I'm going to go through the troubleshooting process and share with you what I have learned so far. Obviously, I'm not a burner oil technician, so I don't know very much about this stuff, but I can at least troubleshoot it a little bit. And what we're finding is the motor, it's just Carlin burner, does not want to spool up. We're going to go through the steps here and see exactly where this is hanging out. I think that the transformer is bad. So apparently the burner just does not want to spool up. We actually applied power directly to the burner and it did spool. So it tells me that for some reason this is locking it out, and I don't think it's the safety switch because we're able to press that and reset it and it still doesn't want to spool. So here we go. So first thing we're going to do here is test and make sure we actually have power. That's usually a good place to start. I set my meter to voltage and AC. I can touch the ground. I want to touch where the power comes into the main shutoff switch. And we do actually have juice. 116, 115, that's correct. Okay, so we do actually have power going to the switch. So if we have power going to the main switch, which is off, then we're going to assume that the switch works, which it actually does, we know that. But the switch does turn on and off, so then what we can do is we can trace the power. So Al, can you shut the power off at the breaker again, so while we're testing this we can double, triple check what's going on. So what we try to do is then try to trace out the wires, but I gotta make sure the power is off so I don't get hurt. I have a tendency to get electrocuted. Okay, so let me zoom in here so you can see the electrical box. So we have the electrical box pulled apart and you can see power is coming in. This is the main, where the main power comes in to the emergency shutoff. When you throw the switch, you have power here. Now there are two lines that exit there. Somebody's wired this in that way, and I'm not the electrician on the job here, so this looks kind of sloppy to me. Whatever. Okay, so power goes two places. It goes to this black wire here, and that black wire actually travels down this and goes, and we'll trace that out later, that actually goes to the transformer on the burner. So it's constant power. The second power here, second black line, goes to two lines. It splits. One line apparently goes to a unit up here, which is that guy, some type of pressure switch, and I'm not super familiar with exactly what that is. It's a cut in, cut out pressure switch, so we'll have to figure out exactly what that does. So the black line goes up there, and if this pressure switch is satisfied, then power comes back down through another black line. This black line goes all the way to the water feed, so it actually supplies power to the water feed. This red line also supplies power to the water feed, and it's funny, as I'm looking at this and thinking about it more and more, I think the water feed needs power constantly on this black line, and then on the red line we'll need power intermittently if it's instructed to feed. Anyway, we're just trying to get this working right now, so I'm going through troubleshooting on exactly how to get the power traced out. Anyway, so this is power supply to the water feed solenoid, which is way in the back, which we don't worry about for now. We also have a bunch of lines here. These go to the low water cutoff. The low water cutoff actually does two things. At least this low water cutoff does two things. One, if it senses low water, it will shut down the burner, but it'll also turn the feeder on. So it actually turns the water feed on. Now you can see here's a sight glass. We actually do have water in the sight glass, so we're not worried about having water in the boiler right now, or too little water in the boiler right now, rather. But what we are worried about is if we don't have the low water cutoff wired in, somebody's undone this. If we don't have the low water cutoff wired in, eventually, if you run this enough, you can run it dry and then you can have an explosion. So, don't do that. So let's see if we can get the burner to fire. That's the main goal of tonight. Even if we don't get the whole thing running, that's not necessarily my objective. If we can just get the burner to reliably fire, then we'll be doing good. So let's go down to this wire mess here, which should actually be pretty simple. Thermostat's wired in, and this is the eye, which actually detects light. Inside of here there's an eye that actually detects whether or not there's a flame. If there's light, that means there's a flame. If there's no light, no flame. If there's no flame, then it sends a signal back to here after a certain amount of time to shut the burner down. And they have different settings on these as to how long the trip is. So I'm just going to install a new one of these. We're going to play a little part starts and see if this whole thing fires up. Actually, Al, let's turn the breaker back on and see if we can show whether or not it actually goes or not. We have verified that there is fuel that comes out of the fuel pump. Whether it's getting clogged in there or not, I don't know. But let's see what happens when we hit the on button. Again, the thermostats are satisfied?
Yeah.
Okay.
I jacked it way up.
I heard a click in here, but I don't hear anything going. So either this is wired improperly, which I've checked it, or something's actually wrong with this relay. Most likely, at this point, I think something's wrong with this relay. So I'm going to turn the power off here, and I can hear the relay click here, but nothing's actually happening. So let's see if we can replace this. I'm just going to wire in the new, and this is pretty simple. We're just going to do colors to colors, okay? Orange happens to be going to the actual blower motor itself. Blue here goes to the igniter, the transformer. All the whites get tied together here, pretty simple. Reds to reds, and blacks to blacks. Black is, again, the main power that came from the top here. The interesting thing is the red, at least to me here, the interesting thing is the red at this point only seems to be, well, it seems to be equivalent to the black. And I don't get that because this is a 120 volt circuit, so they're identical. Now, I'll wire it in. I'll wire in the new one and see what happens. So I've got everything apart, and the new, what is this actually called here? 15-second lockout. This is a oil primary control. This actually happens to be a Honeywell part, but the new part is pretty simple, and all these things are actually labeled well. So igniter, motor, valve, limit. So yellow to yellow, red to red, purple to purple, blue to blue, all that stuff. And you'd think that sometimes between companies you wouldn't necessarily have the correct color coding, but apparently it is. At least it looks right to me. What's cool is actually if they actually gave me more wire leads, I could put all the other whites on here and just tie them up individually, but it doesn't matter. It does not matter. Just put all these wire leads on here and then wire this thing up. Maybe it'll actually run. I don't know. Again, double, triple check that your power's off when you're doing any of this sort of stuff. I've gotten electrocuted one too many times. So mostly because some other idiot wired 2 circuits into a 1 circuit box. Besides the point. Okay, here we go. So I'm gonna just simply put all these together, and I can go trim up these wire leads later if I really choose. Just gonna wire this in, and I'll just match up the colors. Pretty simple. We'll go from there. Again, I just want to demonstrate on this video that I've learned a few things. I'm not trying to instruct people on how to do this, because I am not a boiler tech, but I just want to show that I've learned a couple of things. So here's the eye that detects light. And here are the electrodes, which actually touch those electrodes down there. And there's a valve here, which actually determines whether or not oil is going in or out. Now that may actually be part of the problem. No, it isn't, because we actually pulled, there's a copper line over here that you can just undo, and we actually pulled, that's actually before the copper line. Aha, it's in line with it. So the copper line was shooting fuel out into the pan here, so we do know that we are getting fuel. So that's good. Anyway, these electrodes actually happen to touch 2 electrodes here, and then they meet in the middle, and they spark as fuel is jetting out. And just looking at this, I am not concerned. So, this looks brand new. We can test this later if we absolutely have to. Find out that it isn't working. So we're wired back, all the red to red, purple to purple, blue to blue, orange to orange, and everything looks like it's in the right spots. The thermostats are wired in, and one way to tell whether or not the thermostats are calling for heat. No, that's a box, but not a box extension. I have a box extension at home. I'll go grab one. One way to tell whether or not the thermostats are actually calling for heat is that it should be a short circuit like this. That's a short circuit. So you put the put the 2 leads on the thermostat without power, of course. This is a short circuit, which means the thermostats are closed, which means that they are calling for heat. They're telling this whole thing to turn on. What a bowl of spaghetti, huh? The longer you stare at this, the more simple it actually becomes. So sometimes it takes a few days to sit here and stare at this sort of stuff, but once you stare at it, it actually starts to make a little more sense. It's a matter of sitting here and looking at it and thinking, well, this goes to there, and that 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 goes to there, and all that stuff. You go through all that process. But you got to flip the breaker over there.
I can do that.
You flip the breaker, and we're gonna see how this goes.
Put it on, right?
Okay, make sure it's on.
Yep.
All right, so we're wired up. We should have power going to this. Let's see. We're gonna flip the switch and see what happens.
Is there a reset switch on there?
It says stand by. Call for heat. There it goes. She fires.
Oh my god, dude! I don't believe it!
Alright, we're gonna shut this down because again, we don't know exactly what we're doing, but it does fire. So we're in good shape. We did it.
Dude, it's fired up! Got it!
Okay, so let's explain where we're at. We know that it fired. We're all excited about that. Because somebody said the burner was bad. Well, the burner's fine. Apparently, it was the controller that went bad. So now what I'm trying to do is I'm trying to trace the wires and figure out what goes where and what goes to what and all that stuff. So let's talk about the low water cutoff and where I think it goes, and somebody can feel free to correct me if I'm wrong. There are 3 wires for the low water cutoff that are actually in this line here. So let's see if I can no, it's right there. Perfect. So there's electrical line that goes to low water cutoff. So what happens is real simple. Power is supplied via the black line. That's got to be always hot. So I have to connect that with some place that's always hot. If this senses low water, it trips a switch in here and sends a signal through 2 yellow wires at the same time. So 120 volts will come out of both of these if this senses low water. Where do you want that to go? Number 1, you want it to go to the automatic feed, which is in the back over there, which we won't worry about for right now. You want to actually send a signal to the feed valve to feed water into the boiler because you have low water. 2, you want to shut the burner down so at the same time until the water level is satisfied. So I'm trying to figure this out. There is on here, on the controller, it says, the red line says limit. Well, it seems to me, this is the red line that goes to that limit. The red line here is crimped in with constant power. Well, that's not good. How is that ever going to, how is the low water ever going to shut down the boiler? Well, it can't like that. So I need to wire in this yellow line to this red. The yellow line is a limit switch. As soon as this detects that there is an issue like that, then it should just go. What do you think? Good idea, bad idea? We'll see.
And then we'll do that.
Burn his first teeth later.
So now I'm going to diagnose the low water cutoff. I'm not going to actually test it to see whether or not the float is stuck. But what I'm going to do is I'm going to see exactly what contacts are closed and what contacts are open. I would anticipate that the contacts right now are closed. So, and that black is probably common. Not closed. Not closed. Those 2 are common. So right now the switch is open.
Which it should be. There's
need-
water in front of us.
I need to be able to test the switch. That's the
Is
problem.
that the thing?
Need to be able to test the switch to figure out exactly what's going where. By the way, we figured out that the limit down here on the controller needs to have power applied to it to run the burner. If you remove power to the limit wire here, the burner shuts off, which I think is part of the idea here, is that if this senses low water, you want to shut this down, but you want to remove power to it as opposed to add power to it. So now we've got to figure out exactly what's going on with the switch in here and what contacts are closed, what contacts are open, what opens and closes, and then we can actually wire it appropriately.
I haven't heard it run in 2 years. 2 years it hasn't run.
3 wires going to low water cutoff. One of these wires is common. It should be the hot wire or hot all the time. And I'm trying to figure that out. I think it's one of the yellow ones instead of the black. Should be the black, but let's ignore that for the moment. It's that one. Not this one's common right now because the switch is going to that side. Oh, how the heck? Oh, I know how we're going to figure that. Pull that off. So now we know which one it is. This one. So this one's got to be hot all the time. So now we have to mark this with some tape or something like that. The reason that I know that this is going to be the hot all the time, this is on one side of the switch, this is on one side of the switch. So when this is hot, then right now this one's hot, which means the boiler is going to run. If the low water cutoff hits, then this will be hot and this will be cold. This goes to the limit, this goes to the feed. Pretty simple, basic. Hopefully the idea works. We're going to test the low water cutoff by pulling water out of the system and seeing if I'm actually correct. So again, let's see if we can find some tape. Some tape. So what I think is that right now the low water cutoff is satisfied. There's water in there. Therefore, these two are tied together. If we drain water out of the system, we're going to find that these two are tied together. At least that's what my theory is. Let's drain the water out and see what happens. Yes.
It switched already?
Yeah, we
Turn it
switched.
off. It switched already?
Perfect. Turn it off.
So you know, so that's functioning.
So now we know that the low water cutoff works because now these are tied together.
It did switch, yes?
It did.
Awesome.
Now these are back, but these were tied. Do it a little more, Ed.
All right.
Yep. Now this should stop beeping. Go turn it off. Nope. Yep. Stop beeping. Now these are correct. Okay. So now we know when the water level is going down, you want to feed the system. So then we're going to need power. It's going to be power that's going to go to here. So when the water level comes down, we're going to have power that goes to the auto feed, which is this red line. When we have power, when we have normal operation, when there's water in the system, we want the power to be applied here and power to be applied, power come out of this yellow one and go to the limit switch down here, because the limit switch is what governs whether or not this actually turns on or off. As soon as low water situation happens, the limit switch then will not have power applied to it, and the burner shuts down. So far, we're doing good. It's working. So what we have here with the low water cutoff, if I can summarize, we have constant pot going in, and when there's enough water, power comes out through the other yellow line and goes into the limit switch down here. The limit switch needs to have power applied in order to turn on the burner. In the case of low water, power will be cut off from the limit and will be applied to the feed mechanism in the back. That's the idea anyway. That's the ticket, ladies and gentlemen. Right there, you have it. It runs. Unreal.
Through the dice.
We rolled the dice, we played part starts, and this time we won.
Yes!
Doesn't happen all the time, but we're going to call it a wrap. That's good. We have a low water cutoff that works. We've tested it. All you got to do is open it and make sure that water comes out, and then you also make sure the boiler shuts off when you do that. Check that the water's in the sight glass, which it is. Kind of dirty water, but it's there. We're wired, ready to go. Gotta close all this up, and we're done. Have a good night, ladies and gentlemen. That's about what I've learned here. It does actually fire. We'll see if we get some steam. I'll simply sign this off and say thank you for watching, and don't forget to subscribe, and don't try this at home because I don't know what the heck I'm doing.